So we got either like this graph, otherwise we can make it like this also. Now this one states on Robert Boyle, around 16th century it is. I'm not sure what happened, isn't it? Around 400 years, more than 400 years it is. Now, this is the definition of the Boyle's law. For a given mass of a gas at constant temperature, the volume is inversely proportional to the pressure, or pressure is inversely proportional to the volume. You can give anywhere like this. Ultimately, we are getting PV is equal to K like this. Now, here, based on that, we can convert that PV is equal to K by putting what happened, P1 V1 is equal to K, or P2 B, because whatever you take P1 V1 always will be same only. That means what is the meaning of this one? Do you know? What is the meaning of this? You know. So P1 and V1, P2 and V2. P1, P2 will be different. Understood better. V1, V2 will be different. But when you multiply these two, the value you are getting, no, that will be same. This is the important thing. That is the meaning you are putting a K. That means P1, V1, when you add these two, that means, multiply this one, that will be same one. So that is the reason you are putting the constant. That means in this case, when you observe this, this case, here you lost the V1 value, but P1 increased, no? In this case, the second diagram, if you observe here, V1 decreased, but P1, V2 is decreased. That means V1 is decreased, you get what V2 here, but P1 increased, no? In this also, volume is decreased, pressure is increased, no? So that what happened, cumulatively when you take what happened, P1 and V1 and P2, V2 both always will be equal. So based on this formula only, we are doing the formulas. Based upon this form using, we are doing the formulas. The number of formulas we are getting it. See, PV is equal to K. Then P1 inversely proportional to V1, P2 is inversely proportional to V2, P3 is inversely proportional to V3. We are getting P1, V1 is equal to K1, P2, V2 is equal to K2, and P3, V3 is equal to K3. But K1, K2, K3, all are will be equal to what? K. All are what equal? Then P1, V1 is equal to P2, V2, P2, V2 is equal to P3, V3. Why K1, K2 are equal? Because when pressure is increased, volume is decreasing, and cumulatively what happened? The value is becoming what here? Same only, right? Now this is the graph. When you observe here, what happened in slides? Let me see here. The graphical representation of the Boyle's law. I have taken what? On y-axis pressure, on x-axis I have taken volume, and you observe here, from here, if you start the pressure here, you are starting the pressure, and the volume is what happens? Something over here, 0, it is the volume. Now what is happening if you observe? Volume is very low, is something over here, or 0 or something over. At least it will have some value, no? So you state from here like this. Now it is decreasing, you see. It will decrease now here. When the pressure decreases, what happens? Volume will increase. This is the reason we are going to get this type of graphs. This is very simple only, right? At T1 temperature, something like that. Then T2 temperature, then T3 temperature. Okay, but T1, T2 will be, if you observe, T1 is less than T2, T2 is less than T3, right? You are calling isotherm because if you place a graph between what happened at constant temperature, then that is called what? Isotherm, generally we call that. Here it is what? T1, T2. In Boyle's law, always remember T1 is less than T2, T2 is less than T3. For all what graphs only. In this way, we are going to get the graph. A straight line. You are getting straight line beta because you are taking 1 by V beta. In examination, you may get like this examples. You see, when you take pressure and volume, we get what happened? This type of curve, decreasing curve. But when you take pressure and 1 by V, what type of graph you are getting beta? Straight. Why? Because you see, pressure and volume inversely proportional. Pressure and volume, they are inversely proportional, right? But in this case, pressure and 1 by V, they are directly proportional. You observe, pressure and 1 by V, they are directly proportional. We are getting straight line. So in examination, they make you like this also. When you get a straight line, pressure and 1 by V, if they take on x-axis, if they take on 1 by V, you will get a straight line. On x-axis, if they take in volume only, they will get what happened, this type of downward direction, you get the line here. Now, when you take graph like this, PV and P, what is PV beta? PV is equal to K, correct or not? PV is equal to K or not? Tell me beta.
Yes, sir.
Then PV is equal to K. K always constant, no? Then we get a constant like this. In this case, we don't get any change. When you increase the pressure also, see the PV will be constant. That means when you take PV in y-axis, you get a constant, no change. No change in this case. Same values we get. PV never changes because PV is equal to what actually? K never changes. Right? So this is some type of graphs you are going to do. Is inversely proportional to volume. P is equal to K. Already discussed this one everything. Now we can also write density is equal to mass by volume. Correct or not? Density is equal to what is the formula? Mass by volume. Right. Now we put here that value here. I'm putting this volume is equal to what I can write. Volume is equal to beta. Based upon this formula, what is the volume?
Density into mass.
Mass by density. Shall I write like that? V is equal. It will come down like this here. Now V is equal to what? Mass by density. Now substitute this value over here in volume. Now what we get here is equal to m by d. In the place of V, m by d is equal to K. Now P is equal to what we get? K by this density I am putting over here. D like this. This D will go here and m will come like this. Cross multiplication. P is equal to K by m into D actually. But I told you no, mass is fixed, correct or not? What is the statement here? Mass is fixed, correct or not? Moles are fixed, then it will be fixed only, no? K is constant, m is also constant. Why m is constant? Because the law itself is saying that the mass is what? Fixed mass, therefore it will be constant only. K is constant, mass also constant. Then what we get beta here? P is equal to what we get? K into D. Simply I can write P is equal to constant K into D. Now P is directly proportional to density. So you may get one more formula now here. P is directly proportional to D here, isn't it? So what formula you can get? P is directly proportional to D means P. You send this one here. What we get? P by D is equal to constant. Correct or not? You are sending this D where here? Now P by D is equal to constant. In that case, P by D is equal to what? K. Then we can write here P1 D1 is equal to P2 D2. One more formula you got here. This is also important formula for you. So note down this formula beta. P1 D1 is equal to P2 by D2. If they given what happened? D1 P2 P1, we can calculate the D2 by using this one. Right? The formula, remember one more. Next, you'll see that one problem I'm saying. You all of you please read this problem, all of you. Anybody can solve this problem? Is it possible? By using the formulas. By using these formulas. To note down what is V1, what is
V1 is equal
yes,
to
you take formula and substitute in that one.
So the pressure we have to take in Pascal or bar?
Remember, but when pressure is given in the problem as a bar, you take as a bar only, but not much difference between bar and atmosphere. Both are almost 0.987. One is equal to 0.987 means what happened? Only 0.013 is different is there. So not much difference you will get here. Now I am doing this problem beta. You complete that problem. You do own, no problem. A balloon is filled with hydrogen at room temperature. That means temperature is constant. It will burst if pressure exceeds 0.2 bar. If at 1 bar pressure, the gas occupies 2.27 liter volume, up to what volume it can be expanded. So if you increase the pressure more than 0.2 bar, definitely the balloon will get burst. That means below 0.2 bar, it will not burst. And that below 0.2 bar pressure, what is the volume we have to calculate? So what I am taking, there is a relation between volume and the pressure. What type of relation? Volume is inversely proportional to pressure. Then we get PV is equal to K. Then we get P1 V1 is equal to P2 V2. Now what is P1? So if at 1 bar pressure, the gas occupies 2.27 liter value. So take no problem this 1 bar pressure and occupying the 2.27, you take as P2 V2 or P1 V1. That is no problem, initial and final, because if it will burst if pressure exceeds 0.2 bar. This is actually that normal, not in the balloon beta. It is not at the balloon. So normally what happens, you take like this. If 1 bar pressure, the gas occupies 2.27. So I am taking this 1 bar and volume is what? 2.27. Now pressure how much here beta? 0.2, P2. And what is the volume we are calculating? Now send this 0.2 over here. So 2.27 by 0.2. Now you do one thing, 227 you write into 10 to the power of minus 2. Okay. And this one 2 into 10 to the power of minus 1. You can write like this. Understood? Why I have taken 0.2 is equal to 2 into 10 to the power of minus 1. Everyone knows, no? 2.27. 7 into 10 to the power of minus 2. Now 10 to the power of minus 1 will get cancelled. Now 2 ones are, plus what 2 ones are? And
11.35.
So 113.5 into 10 to the power of minus 1. See 113.5 into 10 to the power of minus 1. That will be 11.35 liter. 11.35 liter it is, isn't it? Understood here? So at 0.2 bar pressure, the volume is how much here? 11.3. That 0.2 bar pressure, isn't it? The volume is 11.35. If you exceed this pressure, if you increase the pressure, then it will burst. So how much volume it should have? 11.35. Expand this one, will get what? If the volume is expands more than 11.35, then it will burst. In this way, we have to do the problem. You see, more pressure, less value. Less pressure, more value they got. Right? In this way, we can do the problem. According to Boyl's law, P1, V1 is equal. You can do like this. Answer we got here 11.35. You got 11.35 only the answer. So very simple formulas these are actually, but important thing is that conversions, bar, atmosphere, you have to consider this. Here they given one more. The volume of the certain mass of the gases. Now density is given. Let me see this one also. The volume of the certain mass of the gas is 0.6 decimeter cube beta. The volume is what? 0.6 decimeter cube. You take this V1 beta. Pressure is what? 95.76. P1 it is. Next, calculate the volume of the gas if the pressure is changed to 147. Now this one will be the P2. Now what they are asking here? V2 they are asking. Same formulas, but the units are different here. That is only the thing we have to observe. The units are different here. P1 is 95, P2 is what? 147, V1 is 0.0 decimeter cube, and find they are asking V2. Now, you don't need to change anything better. Don't change this one, kilo Newton meter to the power of minus 2. Don't change anything. That is actually what happened. 1 bar pressure only. No need to change anything, anybody in this case. It is a liter only. No need. Direct write down the same, because they are asking what happened. Do they ask what happened in terms of any other values? No. So directly substitute here. Directly substitute that values here. 95.6, 147, you get 0.38 decimeter cube. Understood? You completed this one. Decimeter cube is nothing but you will get in the terms of liters only there. Understood here? Which law is better? This is very simple, no need to ask. Let me see the Charles law better. Let's see now Charles law. Before which is the textbook here? This is the formula already we have taken. This problem already we are done. So in your notebook, what should be there now, beta? Boyle's law statement. Boyle's law statement we should have now in your textbook. You have to write the Boyle's law statement, this one. Then relationship, this relationship. After that, what happened? PV is equal to K, this one. After that, what happened? This one, formula P1 is equal to P2V2 formula. Then based upon this, we can write this formula. After writing this formulas, you draw these two diagrams here. You draw these diagrams here. Then after this, what happened? You can derive one more formula, this one. Already I have derived this formula. How I derived, I am writing over here. If you don't written that one, I am writing again. Density is equal to what here? Mass by volume. Volume is equal to density by mass. Sorry, what we got here? Just now. Now in place of V, we are getting here mass by density. Otherwise, what happened? You take like this also. Density is equal to mass into 1 by V. Shall I write like this? Now send this mass here. D by M is equal to 1 by V. Now what is the formula? P is equal to K into 1 by V. Correct or not? Now 1 by V is equal to what? D by M. Now put P is equal to K into D by M. Okay. Now we got something here. D by M. Same thing you are getting here. P is equal to K into D by M. This formula we have. Now already I told you mass is what? Constant here. When mass is constant, what happened? P and K by M into D. Now this is everything is a constant. M is constant, K is constant. Now P is equal to what? K into D. Now what you are getting formula? P directly proportional to density. Formula will be P by D is equal to constant. So we can write P1 D1 is equal to P2 D2. Okay, this is the formula we are going to get with respect to what? Density. This actually we have derived that one. So derive this formula also in your text notebook. So with this, what happened? We can complete what happened? Boyle's law. Let me discuss now Boyle's law now. We'll go to what? Now Boyle's law. Now what is this Boyle's law? First of all, let me discuss in the slides here. Now, according to the Boyle's law, when you heat a gas, the volume will increase. You see, this is at what? V1, T1. I have taken volume V1 and temperature T1. When you heat, that means what happened? T1 you are changing. When you are heating means what happened? The T1 is now converting into your T2 because you are changing the temperature. You are increasing the temperature. You are changing the temperature. Now T1 becomes T2 now. In that case, this V1 now will increases. The V1 means that volume will increases. Now what relation we can get here from this one? Volume is directly proportional to temperature. So what is Boyle's law? Volume is directly proportional to temperature. When you heat a gas, its volume will definitely what happen? Increases. That important thing is that here, it is taking place at constant pressure. Whenever it takes at constant pressure, the graphs are called what? Isobars. Previous case, they are called isotherms. Now they are called what? Isobars. Is the Boyle's? Isn't it? At constant pressure, you observe here what happened at constant pressure. Volume of the gas of a fixed mass. Volume of the gas, again here also fixed mass. The gas mass should be what? Same only. Is directly proportional to absolute temperature. Now what is this absolute temperature? Why we got here absolute temperature here? Generally what happened is this absolute Kelvin we call. Absolute Kelvin means what? So at now, can anybody say what is the state of nitrogen at this temperature? Anybody? Which state it will be there? Nitrogen. Which state it will be there, beta?
Gas, sir.
Gaseous
Yes.
state.
H2O will be
Gaseous.
H2O. Yes,
Liquid.
H2O
Liquid.
liquid state.
Liquid.
And if I take what happen, anything what potassium nitrate I am taking. Potassium nitrate in which state will be there? NaCl you take because you don't know potassium nitrate. No?
Solid.
NaCl.
Solid, sir.
Solid.
Solid, sir.
So here
Solid.
at room temperature, if you observe nitrogen is gas, H2O is a liquid, NaCl is a solid. Okay. And all are at same temperature only. All are at something room temperature 27 degrees Celsius. At same temperature, one is existing as a gas, other is liquid, some other is what solid. But what is absolute zero temperature? Absolute zero temperature. Absolute zero temperature means 0 Kelvin temperature. 0 Kelvin temperature means minus 273 degrees, 0.15, something what happened, 0.15 degrees Celsius. Otherwise, roughly you take 273, minus 273 degrees Celsius. Isn't it? Minus 273.15 degrees Celsius or 0 Kelvin. This is called what? Absolute zero temperature. Now in examination, they may give question. What is absolute zero temperature? 0 Kelvin or minus 273.15 degrees Celsius. This temperature can be taken as what? Absolute zero temperature. Now what is the use of this absolute zero temperature? At this temperature, no gas exists. At 27 degrees Celsius, some are gases, some are water, some are solid. But at this temperature, what temperature? 0 Kelvin temperature, you cannot write gas molecule, you cannot write what happened, gas, you cannot write liquid, you can write only what happened, solids only. No gas exists. Isn't it? Absolute zero temperature, gas, the volume occupied by the gas will be zero. At absolute temperature, the volume occupied by the gas molecules are zero only. That means there is no gas exists here. Gas never exists at this temperature here. So this everything that this you are explaining, no, volume directly proportional to temperature. This is at what we are explaining at absolute zero temperatures. Okay, but we can take that one for different temperatures. V1 by T1 is equal to V2 by T2. So with this is a formula we are going to why, because when you remove this proportionality, V is equal to KT. Right? Now send this T over here. Now we get V by T is equal to K. Then based upon V by T is equal to K, then V1 by T1 is equal to V2 by T2. V1 by, V1 by T1 is equal to what we can write? V2 by T2. Then you send this one over here, what we get? This formula. When you send V2 here over here, we get this formula. V1 by, isn't it? T1 that is equal to what? V2 by T2. Now, V1 by V2 is equal to T1 by this formula. Okay. When you send like this, V1 by, send this V2 over here. Now T1 over here. So V1 by V2 is equal to T1 by T2. We get both formulas are easy, right? Any doubts regarding beta in this one?
No doubt, sir.
Now, when you observe what happened, we'll take some slide over here. Imagine hydrogen gas in a vessel at constant pressure. This is the hydrogen gas beta. Okay, here you taken whatever you're taking hydrogen gas. The pressure is constant only, something 1 atmosphere. You just take as a 1 atmosphere only, constant it is. And temperature is 0 degrees Celsius. And I am increasing temperature how much? 1 degree Celsius. Increasing temperature up to 1 degree Celsius. Then the change in the volume is, isn't it? The change in the volume is observed here. Something what happened? This hydrogen, now volume V1 to what? V2. Now volume is increased here. Yes. Increasing the temperature one more time, 1 degree Celsius to now. One more 1 degree Celsius. Again, the volume further what happened? Increased. Again, it is increased. If increased by 1 degree Celsius, again it is increasing here. Now here 0 degree Celsius to 1 degree Celsius, the volume is V0, V0. At 1 degree Celsius, it will be a V1. Now, how to calculate the V1 value now? Now V0 plus 1 by 273 into what happened? V0. Now here, what is this a meaning of this one? What is the meaning of this 1 by 273 into V0? See, now what I am saying, when you increase 1 degree Celsius, when you increase how much temperature beta? 1 degree Celsius. In that case, how much volume is increased? In that case, you take absolute zero temperature. At absolute zero temperature, minus 273 degrees Celsius, isn't it? How much amount is increased here? With respect to what happened? Initial value. That means with initial value, V0 is initial. Within the initial value V0, 1 by 273 part is increasing here. Okay, for example, initial value is 1 liter. Initial value is 1 liter. In this is V0 actually. Now V1 we are calculating. Now what is V1? V0 plus how much X increased here? How much amount of X increased? This amount of X will be what? Initial value into 1 by 273. Initial value is how much beta? 1 liter. I have taken initial value 1. The 1 into 1 by 273, therefore 1 by 270. For example, if initial value is 2 liters, then 2 into 1 by 270. Like that you have to do. So in that case, what happened? This is the initial volume. This will be the final volume. How much volume increased beta here? 1 by 273 into V0. That means 1 by 273 part of initial volume is increased. For every 1 degree Celsius. When you increase, what happened? For every 1 degree Celsius, the amount increasing is how much here? V0 by 273 part amount is increasing here. For every 1 degree Celsius. Now you go for 1 to 2 degrees Celsius. How much again? Now V1 into 1 by, because this will be the initial value. 1 degree Celsius will be what? T1 and V1, and this becomes what? T2, and this one becomes V2. For this one it is a V1. This one will be T1, and this one will be V2 and T2. That means every time when you increase the temperature 1 degree Celsius, every time when you increase the temperature 1 degree Celsius, what is happening beta? How much volume is increasing with respect to initial value? For every 1 degree Celsius, how much volume increasing beta? At every 1 degree Celsius.
1 by 273 into V0.
1 by 273 of what? Initial value is increasing here. Now, if you observe what happened, 0 degrees Celsius to 2 degrees Celsius here. Now, what you are taking here, you see, this is you are taking initial temperature, you see. Now, 0, I am not taking 1 degree Celsius here. I am not taking 1 degree Celsius over here. 0 to 2 degrees Celsius. Now, again, what you are taking? 1 by 273, this is the initial value. This is the initial value. So, you have to take initial value 1 by 273, isn't it? Now, V0 plus initial. That means initial means you can't say what happened, sir. It is first time, no, not like. We are comparing which value is better, V1 T1, V2 T2. Something like this. V5 I have taken 5 by 270. Again, I have taken initial value. So initial value only we have to take it. Don't take what happened. V3, V4, you don't take it. Understood here? We are taking V0 only. They are taking what? V0 only. Because this will be what? V1 and what happened? T1. This will be what here? V2 and T2. So when you change the temperature 5 degrees Celsius, this will be initial temperature, this will be final temperature. So definitely the initial value will be V1 and the final value will be V2. Now you have to take again 273. But how many times it is? 5, no. So you take here 5 by 270. Here what? 2 by 270. Here you have to change only. Not here actually. This will be V0 only. This will be V0 only. So for 1 degree Celsius, 1 by 273 into V1. For 2 degrees Celsius, 2 by 273 into V naught. For 5 degrees Celsius, if you change, what happened? 5 by 273 into V naught. Now here, whether we have to apply this formula to all type of questions, if they given what 5 degrees 70, no need to do this one. To explain this theory only I have taken. So definitely you take what same formula V1, isn't it? For deriving the formula only, we are taking this expression actually. Finally, what expression we get? Let me see this one. To do this one. This formula you got. What formula you got better? V1 by V2 is equal to T1 by T2. You forgot this one. So in this case, no need to remember this everything. No need this one. I'm not explaining that one because no need for you in examination point of view. This formula is important for you. So all of you practice the formula. V directly proportional to T or Vt is equal to K. Remember this formula, you will get everything. Next, only we'll do some problem over here. If a formula graph here, Charles' law, directly proportional. We are going to get straight line here. Definitely, we are going to get a straight line like this. Straight line we are going to get. Now it is called isobar because this graph is what at constant pressure. Therefore, it is what here? Isobar. At constant pressure, we are taking no. So it is called what? Isobar. Now, if you take what happened, 3 different pressures here. Volume at this constant pressure P1, P2, P3. Now, in this case, what happened? P1 is less than P2, P2 is less than P3. You are observing in this case. In this case, what you are observing here? P1, P2, P3. You see P1, P2, P3. You are observing what happened? This type of things. Now, questions are important for you in examination point of view. Is it possible for you solving this type of question? All of you read the question.
Yes, sir.
What formula we have to use here? This one, just imagine this is a T1.
The V1 by V2 equals to T1 by T2.
This one will be on ship sailing in Pacific Ocean, where temperature is 23.4 degrees Celsius. A balloon is filled with 2 liter air. In that, a balloon is there, and the volume is what here? 2 liter. And what will be the volume of the balloon when the ship reaches Indian Ocean, where the temperature is what? 26.1 degrees Celsius. At Pacific Ocean, temperature is 23.4 degrees Celsius. And the balloon which is having in that ship is what? Having volume 22 liter. And if they're reaching at Indian Ocean, the temperature is what? 26.1 degree. Definitely the volume will increases. How much it will increases? The formula you have to take here like this. Now remember one thing here, whenever you are substituting the temperature value, we have to substitute in terms of Kelvin only. Don't substitute in degrees Celsius. Even though they given degrees Celsius, convert that one into Kelvin. How to convert into Kelvin? Kelvin is always equal to 273 plus into degrees Celsius. To observe how much degrees Celsius they given? 23.4. Add 273, you will get the Kelvin. How much temperature they given? 26.1. Add 273, will get in terms of Kelvin. Now what formula we are taking beta? T1 by T1 is equal to V2 by T2. So substitute that one. What we get? V2 is equal to what we get better? 2 into 299.1 divided by 296.4. Then if you then cancel this one, what happened? We get 2.0188. This is the problem spectrum. Now do one more problem here at constant atmosphere pressure. The pressure is constant beta. At constant pressure, 2 moles of oxygen at 298 Kelvin. At 298 Kelvin, the volume is 49 decimeter cube. So V1 we got 49 decimeter cube, and temperature is how much we got? 298 Kelvin. T1 is equal to 298 Kelvin. Next, what will be the volume of the same amount of, here this is same, constant, moles are constant. Pressure also what? Constant. Charles law we have to use here. And temperature here what happened? 400 Kelvin temperature. Now temperature increased to 400 Kelvin. What will be the V2 they are asking? What will be the V2? Constant pressure means Charles law we have to take here. Take again Charles law here. V1 by T1 is equal to V2. Now V1 substitute what happened? 49. T1 298, T2 400. Then what we get here when you substitute like this? Substitute everything. 400 by 40 into 49 by 298. Now after doing this one we get 65.77 decimeter cube, right? This will be the answer here. Now here also very simple formula, one more formula. Volume is given 0.25. Temperature 300 to 360. You can do this formula very easy. Okay. Right, in this way you will get a number of problems here. Same problems. Now I'll do one thing. I'll do one thing here. देखो बेटा decimeter cube, all of you please listen बेटा. Decimeter cube means nothing but a liter beta, 1 liter. 1 decimeter cube means what? 1 liter. 1 centimeter cube is equal to 1 ml. Remember these two things. 1 decimeter cube is equal to 1 liter. 1 centimeter cube is equal to 1 milliliter. Isn't it? So it will be useful for you. Next. I think this everything you know in the physics, it will be there in everything. 1 decimeter cube is equal to, you can also, deci means what happened, 10 to the power of cubes, we can write in terms of what happened, centimeter. This is also useful for you. 1 decimeter cube is equal to 10 to the power of 3 centimeter cube. 1 meter is equal to 10 decimeter. 1 meter cube is equal to 1000 liter. 1 meter cube is equal to 10 to the power of 3 decimeter cube. Something reversely they are taken like this. Otherwise, 10 to the power of minus 6 meter cube is equal to 1 centimeter cube. 1 meter cube is equal to 10 to the power of minus 6 centimeter cube. This will be useful for this barometer. Now, here. Generally, what happened? The Pascal formula, force by area, pressure is equal to force by area, force is equal to Newton, area is equal to meter square. You get pressure is nothing but Newton per meter square. Now, in this case, what happened? The pressure, if I take what happened, 1 atmosphere, it will be is equal to what? 1.01 into 10 to the power of 5 pascals here. So 1 atmosphere is equal to how much better? 1 atm is equal to how much? 1 into 10 to the power of 5 pascals. Simply 10 to the power of 5 pascal. 1 atmosphere is equal to 1.01 into 10 to the power of 5 pascals, or simply 10 to the power of 5 pascals you have to remember. This can also, we can write 100 kilopascals also, because kilo is equal to what? 10 to the power of 3. So you can also write like this also. Or 1 atmosphere is equal to 7. This is very, very important for us. 1 atm is equal to 760 mm pressure in terms of mercury. This is very important. 1 atm is equal to 760 mm pressure actually. Isn't it? Now this is temperature, already you know this one. How to convert degree into Kelvin by adding what? Use 273. This one. This one is useful. Nobody asks degree Celsius, leave it this one. Just you need what? 270. This one only we need. This one nobody asks this one. And density is equal to mass by volume, already you know this one. This rate of diffusion, no need for you, leave it this one. So this is about today's class beta. How many are there? 53. 54. So I will take attendance now, beta. All of you stay with me. Abhishek Y. Sharma, Abhishek Y. Aditya, Anshu,
Present, sir.
Anuj,
Sir.
Present, sir.
Akruti,
Present, sir.
अनुष्का एब्सेंट है ना बेटा? अनुष्का, अपूर्वा, आशिफ, अतुल रावत,
Present.
Present, sir.
आयुष, Almukund yesterday absent.
Present, sir.
Why बेटा?
Yes, sir.
चैतन्य,
Present,
Sir,
sir.
I went.
चैतन्य, दीप्ता,
Present, sir.
ज्ञानेश्वरी,
Present, sir.
Present, sir.
गुलाबी, कल्पेश, कौशल,
Present, sir.
कृणाल,
Present, sir.
मनोज, मयूर,
Present, sir.
ओजस,
Present, sir.
ओमकार,
Present, sir.
ओमकार पीसी एब्सेंट है?
Present,
ओमकार
sir.
पीसी, ओमकार is absent. समीक्षा,
Present, sir.
प्रथमेश,
Present, sir.
राघव, राहुल, राज,
Present, sir.
Present, sir.
राज,
Present, sir.
रिया,
Present, sir.
Present, sir.
Present, sir.
सपना,
Present, sir.
सार्थक,
Present, sir.
शशि,
Present, sir.
स्नेहा जी, yesterday absent स्नेहा जी,
Present, sir.
स्नेहा VS, after long time you attended class, Sneha VS,
Sir, you didn't take my name.
Present,
I will take minute. Sneha VS, after long time today you have attended class. So do you frequently attend? Otherwise, what happens? Frequently absent to the class. Tell me one thing. If you want to attend regularly, then attend the class. Otherwise, what happens? Leave it. I am saying to see Sneha VS. Attend regularly. Tomorrow onwards, I will watch you. Suraj, Suraj, you, Suraj, you,
Present,
Suraj,
sir.
Suraj C is absent. Swastika,
Present, sir.
Triambak,
Present, sir.
Umesh, Vaishnavi Jadhav,
Present,
Present,
sir.
sir.
Vaishnavi Nichal,
Present, sir.
Vaman absent, Vedant, Vishal,
Present, sir.
Yes,
Present.
Bharati absent, Bharati is there?
Present, sir.
Yes. आपका नाम नहीं आ रहा है इस पे बेटा डिस्प्ले में
सर है वहाँ पे ऊपर है
हैं पल्लवी
सर है
पल्लवी पल्लवी के नाम इस पे नहीं है ना पल्लवी एब्सेंट राइट वामन आल्सो एब्सेंट वामन एब्सेंट सूरज सी एब्सेंट सूरज सी Suraj C. Absent. Right. Sumit AM. Absent. Sumit present. Sumit AM present. Right.
Present, sir.
Okay. Okay. Srihari. Your name is not coming yet.
Present, sir.
Right. Suraj C is absent. Right. Sahil. Sahil. Are you there? Sahil. Absent. Omkar PC. Omkar PC. No. Absent. Anushka. Are you there, Anusha? Anushka? Anushka absent. Right. Okay, beta. You can leave now.
Thank you, sir.
Sir, Tejasvi.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Who beta?
Sir,
Thank you, sir.
sir, you did not took my name.
I have took your name I have taken. Tejaswini, no.
Sir, no, you have not
You did
taken.
not respond, but I took your name. Tejaswini, after
Okay,
this,
sir.
I called you, but you didn't respond. But I have seen your name on here. So I given attendance to
Sir,
you.
actually, I did not hear your voice. That's why.
Okay, okay. If I see the name, I will put attendance beta. In display, if I see the name, no, then definitely I will put the attendance. But if I see the name and if you don't respond, then I will put absent.
Okay. Thank you, sir.
Okay, beta.
Sir, I have a doubt, sir.
Bolo beta.
Thank you, sir.
Sir, ice has lower temperature than the water. Then how the ice has more volume than the water, sir?
See, at 4 degrees Celsius beta, there is a exception is there. 0 to 4 degrees Celsius, ice will float on the water. Isn't it? That is an exception case what happened. The density, if you observe what happened, the arrangement in ice what happened, that because of that arrangement, tetrahedral arrangement what happened, that ice will have less density than water. At what temperature? 4 degrees Celsius. 0 to 4 degrees Celsius, the density of ice will be lesser than the water. Therefore, ice definitely will float on the water. That is an exception case for us because of the arrangement of atoms in the ice, isn't it? So in that case, what happened? The volume in that occupying by ice water, no, ice molecules in the volume, that volume is getting what happened more when you compare with water. So in water and ice, generally what happens, volume of salts will be more. Generally, if you observe, the volume of the salts will be more. But what happens because of the arrangement? No. So volume suddenly what happen increasing. So density what happen here decreases. So suddenly density is volume is increasing. So density is decreasing. No. So ice will float on water. That is around 0 to 4 degrees Celsius.
Okay, thank you, sir.
Okay. That will come in hydrogenated compounds.